It's me. Okay, draft science video. Yeah, physics number 30 on this revolution thing. So far, so bad, but it's it's all work. Life is work. It's a lot of idiots in the universe. Um, this part of the universe, anyway. So the last video, it really wasn't a bad video. Look, one like, 12 dislikes. I mean, it's just, 123 views. Just quite hilarious, actually. I don't think people could argue with what was in that video. I just don't think they can. In any kind of rational way. So, yeah, some Jesus person, I don't know, asked for magnetism stuff, but no point. And then this, whatever this guy is, Emergenton, whatever, blah, blah, blah. Crazy person. No point. You aren't half as smart as you think you are. Yeah, that's really a great counter argument. Thank you. It doesn't really matter. I'm still like 9,687 million times the speed of light squared, kind of smarter than you. I don't know. Inmendum equals gay, or maybe an ex-drag queen. Very good. So anyway, just rubbish. But anyway, so I'm going to try a new style. As you might notice, the background will be different. Eventually, maybe I'll just do editing words in there and stuff or something. But I got to try some different style bits, and so we'll just kind of move along. The next video will be one again. We'll start over, and some slight change in the title, I suppose. Maybe I'll capitalize the A. Anyway, something simple. And so this video, I'm just going to go through some stuff about photons and electrons, and then the restart video will get back to the gravity stuff, the stuff that's the stuff that might really mean something in terms of changing. But I think it makes an important difference in physics' evolution. Because they'll have a better foundation. So anyway, alright, so the energy equals movement thing, okay, we all should be able to agree on that. Maybe. But basically, yes, there's only one element that's moving, and that's photons. And when they're in arrangements or patterns and you move them, it's still the photons have to do the moving. They have to, every step that the universe takes, every step any matter takes, anything that happens that you notice as movement, happens because photons are moving. And they moved there, either as a group or as an individual. And that's how they got there. Mass needs to be redefined, in my opinion, and re-understood as mass just being the number of photons. That's all it really equals. And the difference is that it's kind of directional. So, as I've sort of made the argument, if the school of fish is just swimming in a bunch of random directions, and they're just in a school in a bunch, they're not going anywhere, you could almost argue they haven't got any mass. But if they're moving in a direction, you're going to notice their mass. It's going to be in your face, so to speak, if they're moving at you. So it's just that kind of thing, that the mass is in the photon, and it's in the direction it's moving. And sort of what makes the distinction for matter, what makes matter different, is that the circular thing. They're trapped. They're spinning. They're not going anywhere. It's non-directional. The direction is constantly being absorbed back in on the center. It doesn't get to do the go somewhere thing. Sorry, just need to wipe my face. Post-nasal drip thing or something. Anyway, so it's matter is, as I put it, is arrangement of or as potential. So these are kind of the important words, right? Kinetic and potential. So kinetic energy is something a photon always has. It's always kinetic. But when it's trapped, it's potential. right? I mean, its movement is circular, so it's not really going anywhere that's interesting. It's just going where it's already been over and over and over again. And it's not until you start migrating it or you release it, then it's kinetic, then it's alive again. It's kind of a zombie or dead until you release it again, let it loose. So, but that's all there is. There's just photons, trapped photons or matter. And mass is just a word of saying how much of it is there. So photons have mass. It's just that you're not going to notice their mass until it's pointed at you. I mean, they don't have mass in some other direction. They don't have mass. They're not doing the spiral thing. If a photon's coming right at you, all of its mass is right at you. So it has mass. It just only has mass when it hits you, kind of thing. And this goes back, though, to the argument of the kineticness and recognizing that photons can't interact with photons. They have to interact with trapped photons. So they have to interact with potential, energy potential, photons in the potential state. So that's the weird thing. It's like the living can only marry the dead. There's only relationship that creates any change. Can only be created in the interaction between a photon that's liberated and a photon trapped. That kind of thing. Alright, so next graphics. So the photon. Alright, so it's got no fundamental frequency or wavelength. That'll be the first thing, right? And the simple argument is this idea of an electromagnetic spectrum. There's no electric, there's no magnetic. Those are phenomenons created by electrons. They're created by the things photons interact with. But a photon by itself, floating about, flying about, has only one thing. It just goes in the direction it's going until something forces it to go in some other direction. It's just a thing moving at the speed of light. 186,000 miles a second. Wow, very fast. Instantaneous from perceptual standards, our perception. That's how slow we are moving. Light is essentially instantaneous from our very slow perspective. The speed of this hand compared to the speed of light is preposterously slow. And that makes it more understandable that what the photons are doing is incredible. There's an incredible amount of stuff going on in 1 second of time. There's 186,000 multiplied by a mile of distance in tiny little Planck constants. I mean, you're talking about an incredible amount of frames. I mean, I probably can't even illustrate as like dollar bills stacked to the moon or something. It's a number so preposterously huge. The amount of events taking place in just 1 second of time from a photon's perspective. The amount of movement, the amount of distance relative to its size it navigates in 1 second is just a gigantically huge number. And it's that thing that creates this distance between us and physics that makes physics hard to comprehend, because it's happening on such a scale difference. Okay, anyway. So when a photon is captured by an electron, there's no frequency or wavelength. It's just capturing the photon, the thing, moving the speed of light. And frequency and wavelength are just incidental. They're just something created by electrons. So when an electron releases a photon, it releases it with an arrangement, a pattern of incidence. And there are certain things built into the structure of the electron, its size, how big it is around, and maybe how much it's spinning internally, that are going to dictate what that wavelength of between the photons it releases will be. And it might release 10 photons, it might release 2. But all you need is 2 to create a photon that has frequency. And so it's more of the subject of electrons, so I don't want to get on the subject of electrons, so I'll just go back to the text. that photons are captured and produced or changed in direction by electrons. So an electron can interact with a photon in a kinetic way, in the sense that what went in comes out, maybe with a change in just direction. The electron leaves in one direction, the photon leaves in another direction, and pretty much nothing changes. Or it can be captured by the electron, like 5 of them can go in, 4 of them can come out kinetically, and 1 of them can remain, and that would be a capture. And now it's potential energy, because now it's been captured. So the electron has gained photon energy, photon mass, and it can release it in some future date, and by some frequency dictated by its structure. So yeah, that's probably enough on that. And that photons have directional mass of, or said, that's the game of what they are. Their mass isn't something that can be detected with another photon. So it's not subject to things like gravity, but their mass is detectable in the sense that they will have an impact on an electron. And yeah, their directional potential to change things, their capacity to change the arrangement of an electron, maybe is the safest way to say that. So anyway, moving on. Next graphic. Electrons. So electrons, are probably some kind of round thing, and I think they come in different sizes, in the sense that they absorb, or have the capacity to absorb, photons and become bigger as they absorb photons. And I think in atoms they are I think what creates elements is the fact that there are electrons of specific sizes that connect to each other in specific ways. So you can see it as rings or something. You could say that the standard electron is this big, and that the rings inside the nucleus might be very small, so they're little rings connected to each other that connect to that bigger electron ring, and then that electron has rings connected to it going out that start getting smaller. So I would argue that in materials like radium or something, that the reason that's producing the photons at the high frequency is because they're small. The outer rings are small rings, and so when they release a photon in groups, there are going to be smaller gaps between the photons released, because the ring is smaller. I think it's just it makes logical sense, I think, to think if you're going to think about the rings being connected to each other, inside each other, one ring inside of another ring, connected, looping into each other, as the way that they are connected to each other, and that when you push them into each other, you break them and release photons, and likewise when you pull them apart, you break them, release photons. So, and I think that's the basic function of what's happening, is electrons are being forced together, locked, and then they're being unlocked, and that's the weak nuclear force. I think they call it the weak one, but anyway. Alright, so electrons capture photons still moving the speed of light. So they're still moving the speed of light. They're connected to each other now. There's no space between them, likely. And they're just stuck, like a little, you could look at it as like little puzzle pieces, and they connect to each other, or you can just look at it as if they're, they have maybe they have a V at one end and a V at the other end, and the V's locked together. But whatever the thing is, it keeps them somewhat coherent when they're in electrons, except that they can be broken out of the structure by being hit by a photon. So a photon can knock a photon out of an electron. Alright, so there is no wavelength or frequency, and the electron can release photons at any wavelength or frequency. I don't mean any electron can create any kind of frequency. I'm just saying that certain frequencies will be likely to be released by certain sizes or configurations of electrons. So if it's a small electron, it's likely to release photons in some pattern, you know, with a period, a distance between them, that's likely related to how fast the electron is spinning, or how tight the spin is, or how fast it's rotating, or some mechanism like that. So then also the directional momentum thing, well, I guess the whole gravity thing, but also I think clearly is that a photon can interact with an electron, not be captured or exchange its energy with the photon. A photon goes in, the same kind of photon goes out, or, you know, 3 or 4 photons is more likely the case, is that these photons flying through the air are probably in groups of 4 or 5 or 10 or 12 or 500 or a million, but whatever, they're in a stream of them, and that's why they have that identifying signature of their period. I have made this argument in the previous video, I can make this explanation, but you can sort of understand that if something's, sometimes you have to hit something just right to create an effect on it. You have to have a certain pitch sound to make glass break. So it takes a certain frequency, a certain hitting of the photons into the electron to expose its vulnerability to be broken out of its orbit, or to be something else happen to it. You have to hit it twice within a certain period of time for you to be able to break it free, for example. So one photon won't break it free, but if you hit it with 2 photons within a specific amount of time, then you'll break it free from its bond with the other electrons. Something like that. Perfectly valid, I think, explanation of the phenomenon we observe. Alright, just the directional momentum, so is what's basically being exchanged through all of these interactions. You can't destroy energy, you can't destroy photons, so all you're basically doing is changing the direction photons are moving. So you're either freeing them from a trap they're in, the electron, or you're trapping one, or you're merely changing direction where the electron has a drift, and by hitting it you drift it more. And so those photons are tending to move more in one direction than any other direction, but they're not liberated. But some of their ability to do work or to do movement is being exposed. They're using up some of their movement by moving in a direction that you can see. Instead of just spinning in a circle, they're spinning in a moving circle. So, and then electrons have speed of rotation and spin, centrifugal motion. You know, this part's not, I don't know if it's terribly complicated, but I mean, it just, there's more than one property that electrons have, let's say. So, yeah, the thing is, the string is spinning, that's the electron that's making the hoop. It's spinning internally, and then it's rotating. So those are 2 movements it has. And on top of that, it has a direction that it's pointing in terms of which way the loop is going. And then it has maybe an eccentricity, not a perfectly circular spin, which would create a wobble in its path. Yeah, so I think that pretty much sums that part up. So, yeah, so the quantum mechanics is really about electron mechanics, and the idea of a electromagnetic, the idea that everything's electrical and magnetic is just wrong. It's photons, and photons are doing everything. Everything that's happening is being caused by a photon. There's just no event that isn't a photon doing something. So we have some bad language in understanding what stuff is really doing. Understanding first this idea that it's all about photons moving, the speed of light, and it's all about their direction. And that's really what accounts for matter and mass and everything. Yeah. And yeah, so I'll get to the rest of this. But yeah, it's a simple universe. It's made out of simpler parts. The further down you go, the simpler it gets, not the more complicated it gets. And so I think this diagram. You can have different models for something, and they both, I should come up with examples of that where there was an explanation for something, and then it was found that that explanation was totally wrong. It worked as an explanation, but it had fundamental flaws, and there's a better explanation. And that's just the truth here. The physics has chosen some explanations that, well, yeah, they do answer a lot of the questions, but they're just wrong explanations. And the truth is they had the right one 200 years ago, 150 years ago, or whatever it was. This idea of photons pushing things together, being gravity and magnetism. And they threw it away for, because they didn't scrutinize logically well enough. And so they threw it away for reasons that just aren't justified, that can be explained away. The phenomena can be better explained. So they just threw away the good answer and moved on to answers that just aren't they aren't accurate. They're just not the truth. Like I said, they model it. They have a similar pattern. It's like I said, you're trying to come up with. Like I said, there's probably been lots of examples where people thought something ether in somebody's head, and you cut holes in their brain, let the ether out. And there's a certain logic to the fact that they need to release pressure out of the brain. Even leeches, the idea of letting blood, where that would be there'd be a beneficial effect, but it wasn't for the reasons they thought. Astrology, no, there's nothing there. That's just kooks. Kooky. I guess you could argue, though, that the moon does have an effect on gravity and does have an effect on, our tides, internal tides. But yeah, the rest of astrology is pretty much crap. It doesn't really model anything. It's bad model all over the place. So it's not a good example of a model that actually works, but that has frailties and vulnerabilities that just aren't as easy to see. So anyway, the frailties of bent space is, the obvious frailty is what kind of infrastructure you're going to have to create to bend space. How does space bend? What's it made out of that it bends? All that kind of stuff. It just gets you into all kinds of trouble. So it's not a very good model in that it doesn't really, like I said, it might model the workings of the convergence, the idea that stuff converges and goes down the funnel. But there's lots of ways to create that convergence. Say this. Yeah, well, I don't have I like to say, I'll have to come up with some other examples of failed theories that were kind of good, but they were just wrong. And the theory of bent space is kind of good, but it's just wrong. Anyway, until next time.